Okay, so we're going to find the weight of this shape up here um, based off of this conversion rate, which this conversion rate is in kilograms per cubic meter, so we need a volume, and we'll try to do that volume in cubic meters here. Now, I think it might make sense just because of these numbers. Just go ahead and leave things as centimeters for the moment, and then we'll convert later over to cubic meters. So I want to find the volume. Um, so my thought here is volume is equal to length times width times height for a rectangular prism. So I'm going to find this thing as if there were no holes in it. Okay, so find the volume of this brick with no holes in it. It'd be 40 times 20 times 20. Okay, but now, and obviously when I multiply that stuff, that's 4 times 2 is 8 times 2 is 16. We got 3 zeros there, so 3 10 to the third essentially. So you get 16,000 cubic centimeters. All right. But obviously there are holes in this thing. There's a hole, and there's a hole, and they are congruent holes, but they are prisms, and there's a volume there. Okay, even though it's a um, negative space, it is still a volume. There's occupied space there. So that hole is 12 by 10 by 20. Okay, because that distance right there for this prism on the inside, okay, this distance here is the same as that one. So it's 12 by 10, 12 by 10 by 20. So again, 12 times 2 is 24. And then I've got the zeros there. But now there's two of those holes. Okay, there's this one as well. So I'll double that. I get 4,800 cubic centimeters. So the total volume of this block then is going to be 16,000 cubic centimeters minus 4,800 cubic centimeters, which that equates to, let's see here, I've got it done, 11,200 cubic centimeters. That's the current volume. Now that volume is in cubic centimeters. We want to convert it so that we have um, the ability to use this thing here. So it needs to be in meters cubed. So I'm going to take 11,200 centimeters cubed, and we'll multiply by 1 meter over 100 centimeters times 1 meter over 100 centimeters times 1 meter over 100 centimeters. The centimeters cubed then are going to cancel out, and I'd be left with meters cubed. So this turns into being, essentially it's going to move decimal 6 spots. So 1, 2, 3, 4, 5, so it'd be 0.0112 cubic meters. Okay, so that's the volume in cubic meters. Why do I want to go cubic meters? Because that is my conversion rate. So now I'm going to multiply that by 1,700 kilograms over 1 cubic meter. Cubic meters cancel out now. I get 0.0112 times 1,700, and it gives me 19.04 kilograms. Okay. You could have actually, the way I did this is kind of, two steps. I could have just multiplied right here by 170, sorry, 1,700 kilograms, sorry, over 1 cubic meter right there, and that would have still gotten me to 1904. But you can do it in 2 steps. Multiplication, because the associative property is okay to do both these ways. So that's how I do that first question. Let's see here. Gonna give me a minute. I apologize for this. Earlier, this thing was not working the way I want it to, so I got to delete this way. Alright, so doing this bottom problem, it's very similar. We want to find the volume of this thing. So this is a composite shape, and the way I'm going to do it is I'm going to break it up into a prism up top here. That's a prism. And I can double it to give me this one here. And then I've got this prism in the middle that I can find the dimensions for. And I should be able to find those three. So I'm going to say volume of top, obviously length times width times height. So the length of this thing is 10 meters. So I'm going to put this into, I'm going to put it as 100, sorry, 10 meters times 100 is 1,000 centimeters. So that's my length. My width, I'm going to use is this 5 centimeters. So multiply that by 5 centimeters. And now my height maybe is that distance there, so it'd be 30. And again, those things can be interchanged, what you want to call your height, your width, and all that kind of stuff. Your length can obviously interchange. So I multiply that stuff out, and that's going to give me 150,000 cubic centimeters. Okay, so that's the volume of the top prism up here. I got two of those. Just want to double it, and that gives me 300,000 cubic centimeters. All right. Now I've got to find the volume of this inner prism right here. Okay. So that's the one I want to find. I know that one right now because this distance here is 30, and they're telling me that this here is 12.5, and that's 12.5. That sums to 25. So I know that this distance right here is 5 centimeters. This is 20 centimeters, and this thing is 1,000 centimeters. So the volume of that middle, length times width times height, 5 times 20 times 1,000. Okay, 5 times 20 times 1,000 gives me 100,000 cubic centimeters. Okay, so that gives me then volume of the entire I-beam to be 300,000 plus 100,000, so 400,000, and that's centimeters cubed. So I'm going to change that to meters cubed. So I'm going to put 1 cubic meter there, and then 100 cubed centimeters cubed down there. And that's the same thing that I had when I went 1 over 100 times 1 over 100 times 1 over 100 in this top problem. I just think it's easier to write as one factor here. Then I'm going to multiply that by my 7860 kilograms per 1 cubic meter. Now if we think about this, the centimeters cubed are going to cancel, the meters cubed are going to cancel, and the only thing left then is kilograms. And I multiply that stuff out, it's going to give me a really nice number of 3144 kilograms, and that would be the mass or weight of that I-beam. Okay. This question here is a similar question to these volume questions. It's just asking us to. It's actually similar to this first one where I had to remove some stuff, but we're dealing with different shapes here. Says the log is 3 meters long, has a volume of 19,200 pi cubic centimeters. The log is taken to a mill, and the sides are log cut off to create a square prism. What is the largest possible volume of the square prism? So I got you walking through this. What's the volume in cubic centimeters of the square prism? All right. So if I'm looking at this thing correctly, the log has a length of 3 meters. So I'm going to say that is 300 centimeters. Okay. I'm trying to figure out what this prism looks like. So this prism would be, kind of that shape there. I need to know what the side lengths of this square are. They tell me that the volume of the log, so I don't know enough about this shape yet to figure out those sides. But I do know that that distance right there is the same for the square prism as it is for the cylinder. So I'm going to try to figure out, based off of the volume being 19,200 pi cubic centimeters, can I figure out what that distance right there is? Well, of course I can. Volume for a cylinder is pi r squared h. So right now I know 19,200 pi should equal pi r squared h. Well, I don't know r, that's what I'm looking for, but I do know h. to be 300 centimeters. Okay, we'll divide both sides by 300 pi here. 300 pi. So that cancels, cancels. Leaves me that number right there. So the pi's are going to cancel. So 19, essentially 192 divided by 3. 192 divided by 3, I think gives me 64. It does. So it gives me 64 is equal to r squared. And this would be centimeters squared now, because this was centimeters cubed. We divided by 300 pi centimeters, so it leaves me 64 centimeters squared. I square root gives me 8 to be r. So that is 8, making that 8, and this is a 45, 45, 90 triangle right here. So now this distance here would be 16 over radical 2, or if I rationalize that, it becomes 8 radical 2. Either one of those is fine, but now I know the side length of my prism. So when I want to find volume of the square prism is LWH. L is, we said 300. Okay, width is now the 8 radical 2, and height is also 8 radical 2. So 8 radical 2 times 8 radical 2, that's 64 times 2, so 128. So we got 300 times 128 here. So 300 times 128 is 38,400 cubic centimeters. Okay. As we continue to answer some of the questions here, they want to know what is the volume. So that's the answer to that question. They say what's the volume in cubic meters? Well, that means I just got to move the decimal point 6 spots to the left. So it becomes 0.0384 cubic meters. Okay, moving 6 to the left. And that's using this conversion. 1 meter cubed is 100 cubed centimeters cubed. Multiply that way, centimeters cubed cancel out. Basically divide by 1,000,000 here, and it gives me this. So wood weighs 51.3 pounds per cubic meter. How much would the original log weigh? Well, the original log is that volume. Okay, so 19200 pi cubic centimeters. I need to multiply that by this thing here. I need to multiply it by that to get my weight, but in order to do that, I first need this cubic centimeters to be in cubic meters. So I will make this as 1 cubic meter to 100 cubic centimeters. Centimeters are going to cancel out. And now I can multiply by 1 cubic meter down in the bottom, 51.3 pounds on top. Multiplying that stuff out, so I get 19200 pi times 1 times 51.3 up top gives me 309,4343.1. On the bottom, I get 1,000,000, which is 10 to the 6, or if I want to write it as 100 to the 3rd, that's fine as well. But basically, I'm going to divide this number by 1,000,000, which tells me I got to move my decimal 6 spots to the left, and that turns out to give me 3.094 pounds. Okay, I have seen some people neglecting the think pi when they're doing this, and they're getting like 984, 960 as that number, but you got to have that pi in there. It is showing up right there. So that's how much the original log would weigh. I don't know why I typed that in. That's the same question. Now it says how much would the wood shavings have weighed? Okay, well, I've now got the volume of the log, or the weight of the log. Weight of the log. Okay. I need the weight of the prism as well. Okay. If I take the weight of the log minus the weight of the prism, that's going to give me these little shavings, these little weird segments off the side. So let's find, I got the weight of the original log, I got to find the weight of the prism. Well, I already know the prism's volume right there is 0.0384 cubic meters. If I multiply that by 51.3 pounds over 1 cubic meter, that should give me a weight there. So 0.0384 times 51.3 gives me 1.96992 pounds as the weight of the square prism. Well, now I'm going to take 3.094 pounds minus 1.96992 pounds, and that will equate to, did I do something here? Give me a second real quick. So I subtract those. 3.094 minus 1.96992. I'm getting 1.12408 pounds, and that's the shaving, the sides here that we cut off the prism, or the cylinder to make a prism. One of the other questions that people are struggling with is something like this. You've seen this in your one homework assignment. Kind of want to go through this as a surface area. I'm going to view this first off as just a solid prism. Okay, so solid prism, no holes in it, looking like that. Trying to find its surface area. I'm going to let the top and bottom be bases, so that's my base. So my lateral area is going to be P times H. So, and it's perimeter of the base. So right now, this is 1.7. This here, now be careful, this is in inches right now, so this is going to be 1.7 feet. This will be 4 feet. Okay, got 1.7 in the back here, and I got 4 over here as well. Okay, so 4 feet. So I'm going to have 1.7 plus 1.7 plus 4 plus 4. Excuse me, 11.4. 11.4 is my perimeter. Now H is this 1.6. So 1.6, I'll multiply these together. It gives me 18.24 inches squared as my, sorry, feet squared, as my lateral area of this thing. Now I've got to figure out what the area of these bases are. So one base is 4 feet by 1.7 feet. Okay, so I'll multiply that. 4 times 1.7 gives me 6.8. So B equals 6.8. But I got 2 bases. Okay, so it's going to be 13.6 when I double that. Okay, so now my surface area of this prism with no holes in it is 18.24, my lateral area, plus 2 of my bases, 13.6. So 18.24 plus 13.6 gives me 31.84 square feet. Okay. Now I also have these squares up here that need to be cut out. That square needs to be cut out. That one needs to be cut out. They're the same. And there's actually holes on the bottom that are the same. So I'm going to find the area of one square, multiply it by 4, and remove that from this. So I've got 0.4 times 0.4. Okay, so the area of one of these red squares is 0.16 square feet. I have 4 of them, so I'll multiply that by 4. So give me 0.64. So I need to remove 0.64 from that 31.84 number, and that's going to give me 31.2 square feet. Okay, so that's where I'm currently at with just putting the holes in there. But when I put those holes in there, we create these sides. Okay, we have sides all the way through here, and we got to find that lateral area. Okay, so that lateral area of those inside is P times H. Perimeter is 0.4. 0.4 plus 0.4 plus 0.4 plus 0.4. Okay, so that gives me 1.6. Do it right this way. Perimeter is 1.6, and now my height would be 1.6. Okay, so then that gives me 2.56 as the new area of these walls on the inside. 2.56, but I've got 2 of those, so I'll double that. Times 2, be 5.12. So I need to add that 5.12 into the 31.2. So 31.2 plus 5.12 and that gives me 36.32 square feet. That's my total surface area. Okay, that goes right there. So if one pint of paint covered that many square inches, how many pints will I need to buy? Well, 36.32 feet squared needs to be changed to inches, so 12 inches for every 1 foot, 12 inches to every 1 foot, okay? And then we have, so everything would be in square inches, so then I'd have 1,500 inches squared for every 1 pint. So I multiply that out, should give me 3.48 pints. So how many pints do I need to buy? I need to buy 4 pints. Okay, I can't buy that half pint or the 0.48. I can only buy whole pints. So now I'm going to take that number, 4 pints, and multiply it by 4.93. Multiplying that by 4.93 gives me $19.72. Now we understand that that's not what I'm going to pay because there's taxes. So I'm going to pay 100% of that, and then 6.75% more. So I'm going to take actually this 19.72 number and multiply it by 1.0675. There's paying the 100%, that's paying the 19.72, but then this is paying the 6.75% of that 19.72. So that's going to give me times 1.0675 gives me $21, and nearest penny would be 5 cents. $21.05, and that's the final answer there for how much money it would cost me to paint this thing. Hopefully that helps. I know some people have been struggling with that question.